crew that in an environment that is less than 2 Gs. Those are really important things as we get to space. The ability to do other things while we're there, not just transport to the station, perhaps doing servicing in space, being able to do other activities in low Earth orbit. This is a low Earth orbit vehicle. So what we'd like to look at this is we took many of the fine attributes of the shuttle without the need to have the large cargo bay to do the construction of the station. And we've brought it forward 30 years in its thinking and its design and its materials. And we're able to utilize that as part of a blended fleet for NASA's purposes and for other commercial purposes.
Mike Reynolds, Astronomy Magazine. This is for Mark. Being an optimist, how many flights maximum would you like to see a year, and how many vehicles do you expect to build?
Well, we wouldn't be doing this if we weren't optimists, right? But thanks for the question. One of the key attributes of the vehicle is a composite design. And when you're doing composite design, essentially you're creating molds for the composite, which allows for the building of additional vehicles in a lot less cumbersome fashion than if you're doing one-off designs. The vehicle is also going to be reusable. We saw that even in the shuttle fleet, as complex as it is, we've got many dozen flights out of each of the shuttles. We think we're going to be seeing that and more out of this vehicle. So the idea here is that the vehicle has multiple purposes and it's reconfigurable. If you think of what Boeing did with 747s, they had one really strong design that they turned into many different kinds of vehicles, and we're going to be taking this vehicle in the same direction.
Jim McDade, The Source. We mentioned shuttle development earlier, and one of the requirements for the shuttle was to meet military needs, DoD needs. Does this vehicle, do you have that in mind when you did the design? Is it capable of polar orbital missions and other military type capabilities?
We had in design, actually, NASA, again, did the original design. It was originally meant to be a lifeboat for the space station, for those of you who don't know. It was meant to bring back people from the station. And what we're looking at is, again, to have a vehicle that's highly reusable for different missions. And it could be autonomous or could be piloted flown. So it could be acting as a space test bed for long-duration flights for space. So it is possible that we could do other work, but there's nothing in the works right now with the military.
Okay, I think John Wilford has had his hand up for a while. He's in the back. Raise your hand, John. Right here. Raise your hand.
I'm naturally interested in older things. And I'm interested in if you're going to be using Atlas rockets for the foreseeable future, what are you going to be using 39A for? Is there a future for the pad?
Absolutely. Right now, all the work has been done out on 39B. And if you look out there, you see the fixed service structure coming down. The rotating service structure is already gone. And it appears that it's in disarray out there. And let me tell you, nothing's further from the truth. You see the 3 new lightning towers, the lightning protection system that's out there, state-of-the-art. Amazing. If you go inside the pad, you'll see it's all fiber optics now. All the copper that came out, in fact, we made $621,000 in scrap from the copper that we pulled out of there and poured back into it. All the control systems are digital. The environmental control system for the pad has been upgraded. And so we've used the money that we had for Constellation to make the modifications that we needed for our new heavy lift rocket as well as future human space rockets. What we want is a multi-user capability where you have a clean pad concept with multiple interfaces to different vehicles. So that's 39B. 39A right now, eventually, down the road, when we do go, well beyond our home planet, we are going to want to have 2 pads that we can launch from. But we are looking at commercial applications for 39A. Other agreements are in the works, and we'll see how things work out. But right now, we don't have the money within NASA to maintain both pads. So as we fly out the shuttle, 39A is probably going to sit for a while with the capability to bring it back when we need it or utilize it for other commercial applications. But our goal is to have a Pad B totally up to date, take this time as we transition to put the money into the facilities that will prepare us for the future when we start getting really busy again and have a multi-user concept out there.
Okay, front row.
Hi, I'm Mark Kirkman, Interspace News. This question is for Mr. Ciarangelo. You actually hinted at it a minute ago, so I kind of just want to follow up. You're the only one with a winged vehicle. I love winged vehicle or winged spacecraft, and I know these two gentlemen certainly do. Can you articulate why your approach of the four companies in the CCDDEV, why the winged vehicle is a better approach than theirs?
I can highlight our attributes. We chose this design for a number of purposes. One is that we felt that it was a very safe and well-tested, thought-out design. Using a lifting body spacecraft as this is, we have the ability to land on a runway, coming in at less than 2 Gs. We use less than 10,000 foot of runway, and although we're nominally using the shuttle landing strip here as a landing point, we actually have the ability to land on any runway, which creates a huge safety zone for the flight, both on ascent as well as descent. The other ability for something like this is that it has the capability of doing other missions in space, servicing missions being highest on that list. It's easily configurable for that purpose. And the idea that we were able to take 7 crew in the vehicle, including having that crew come back in recumbent positions if they're ill or sick or on long duration flights, it really does provide an extra margin of safety for the astronauts who are coming back. And there are a variety of other reasons, but those are the primary reasons.
Okay, second row here.
Jeff Schrock with 12 News. This is for Director Cabana or Administrator Bolden. With this design, do you hope to see the public gain interest or see that spark again in the manned space program once this is operational?
Yes. Yeah, absolutely. I hope the public gains, I don't think they should ever have lost the spark. I think all that we're doing to enable commercial space operations, I don't care if it's a lifting body or a capsule, we're going to develop a commercial capability to launch humans into space from the Kennedy Space Center on a U.S. rocket to go to the United States portion and participation in the International Space Station. So I definitely think people are going to be excited to see people launch on any vehicle, but absolutely.
Okay, we got a few questions in the back row over here.
Actually, Mike Wall from space.com. I mean, so yes, one of the kind of big deals private spaceflight is going to raise is the question of safety. And I was just wondering, this is probably for Administrator Bolden, what are you guys going to do to sort of maintain the stringent safety standards that you've had with NASA, and sort of how are you going to convince I don't know, all of the nation that these are high standards, even if you switch over to the private sector?
One of the challenges that we have right now is developing things like human rating standards and other safety requirements on the vehicles. We're working right now with all potential producers to make sure that we are providing as limited oversight as necessary, but the right amount so that we can maintain our responsibility for ensuring the safety of the crew. I've said since I've been the NASA administrator that my #1 objective was safely flying out the shuttle, and we're so close to having accomplished that goal. And then once we get through that, then my goal shifts to safely providing transportation for American and partner crews to and from the International Space Station. And the other thing you all need to hear me say is to other low Earth orbit destinations. You know, an industry is not one destination. That's really, really critical, that we help the industry think of other destinations in addition to the International Space Station. But we intend to provide the sufficient amount of insight and oversight that will satisfy me as the NASA administrator that it's okay for me to put an astronaut on a vehicle. And we're not doing it until those requirements have been satisfied.
Yeah, I think I could also add to that. You know, I look at Mark introduced his team. Yeah. I flew with Jim Voss. John Curry was one of my flight controllers. Steve Lindsay, I worked closely with him, and the same goes for the other companies. These folks know the risks. They know what's involved to fly safely in space, and they're not going to build something or do something that they think is going to put themselves or any of us at risk. They're going to do it right.
Okay, we have time for a couple more questions. This one right here.
Liz Hurley, WAFF Huntsville. You can't help but look at that design and see the similarities, the legacy hardware in the orbiter. Tell me, Administrator Bolden, what about a design for the future for the SLS, the Space Launch System? How close are you to announcing a design for heavy lift? And will it also look similar to perhaps the Ares, if this looks so similar to the shuttle?
Liz, you know, a couple of things I'll tell you. We're going through a very difficult period of time as a nation right now fiscally. So if you look at the President's 2012 budget proposal, it reflected the difficult fiscal times. And we made some really tough choices in putting together the 2012 budget proposal that went to the Congress that's in discussion right now. This is going to be, the decision on a heavy lift launch vehicle is going to be a very critical and very expensive decision for the nation that's got to carry us into this next era that we hope will extend longer than the 30 years of shuttle. So we're close to making a decision on the configuration, but not quite there. You ask about, will it look like Ares? Mark explained one of his reasons for liking a winged vehicle for low Earth orbit operations. For us, it's ideal when you talk about the kinds of things we want to do for humans, bringing them back to Earth in contingency situations when you have to lay a crew member down. Unfortunately, when you're coming back from a place like an asteroid or Mars or the Moon, the reentry velocities and the pressure under which the vehicle has to survive is much greater than present-day winged vehicles we think can survive. That's not to say that somewhere down the road someone will come up with a design of a winged vehicle that can withstand the types of reentry challenges that we do coming from deep space. But for right now, any deep space vehicle you see is going to look like a conical shaped vehicle. That's aerodynamics and reentry. And it's just, you know, everybody wants to see something that's going to look drastically different. I hate to disappoint you, but a rocket is a rocket is a rocket. People, you know, I'm not a fighter pilot, Bob is, but fighter pilots people always ask fighter pilots, well, how come a Chinese fighter looks like a Russian fighter, looks like an American fighter? You determine what mission it is you want it to do, and that determines essentially the aerodynamics to which you design the vehicle. So that's why they all look very similar. If you want to go to space, you want to go to deep space and come back safely, it's going to look like a cone, yeah, for now.
We have time for one.
It's going to look like a cone. I mean, Ares looked like Apollo. Apollo looked like Gemini. Gemini looked like Mercury. Just, you know, it depends on how many people you're going to put in it. You vary the size. A conical shaped vehicle with a semi-conical backside that you turn to withstand the reentry heating. That's kind of the basic design that engineering requires. So it's going to look like that. Yes. Yes.
One final question over here.
Ted Oberg from Channel 13 in Houston. Administrator Bolden, it's an old story, but a bit of an open wound at home. Can you explain why why Houston didn't get any hardware? We're grateful for the seat, but we'd like to hear sort of why we didn't get more.
Ted, you know, I will give you the same answer I've given to everybody from every other part of the country that asked the same question, and that would be, you know, before I make any comment, I would recommend that you go back to the folks at home and ask them, you know, what they got from their debrief with us. I would rather have each entity explain why they feel, you know, after hearing the explanation for our choices, why they feel they didn't get it. I don't think it's fair for me to talk about that. You know, it was your decision. Oh, it was definitely my decision, and I did it based on criteria that we had established long time ago, and I just, you know, I'm a Houstonian kinda, but that did not play in my decision. My decision was based on criteria that we had established and a recommendation from a pretty good group of people who looked at a number of different criteria.
Okay, thank you. That's all the time we have for questions, and we have another briefing in this room in about 15 minutes. It's a nice segue to this event, which is called What's Next for NASA. I invite you to stay and listen to that one. Thank you for coming.
Thanks very much. Great. Thanks, Bob. Great.